I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. You're looking at the St. Louis Gateway Arch. It was designed as a memorial to those who left St. Louis and traveled west in our country. It is 630 feet high. It is 630 feet from this side to this side across. It is 60 feet in the ground. Some of you may have heard that you can visit this particular monument. First of all, it cost $13 million to build. Yes, I realize you had scientific notation in sixth grade, but it helps me to review. You get 4 million visitors a year that come to see, and of those, 1.8 are brave enough to get into a little train that goes inside the arch and goes to the top to an observation platform. 1.8 million decide to go up. Subtract that from 4 million, and you'll find out that more than half of the people are content to walk on the green grass, look up, and take pictures of the arch. I bring up the arch because it is not a straight line. Everything that we've done before with systems of equations and linear equations were straight lines. This is the shape of a parabola. A parabola is a quadratic function. This is the introduction to quadratics, or the parabola. It's A1, LQE, A2, and it's also, the supporting would be A1, IF, A2. The I can statements: I can recognize the quadratic graph. I can determine the vertex of the parabola. I can find the maximum or minimum of a quadratic function. Now, my video will go here. These 3 videos you can watch for more information. There's the Gateway Arch, that you can recognize that it's not a straight line. And the difference is, we used to have y equal x. Now we have y equal x squared. If the x squared term, that is, if we have an x squared term and a middle term and a final term, then we're talking about a quadratic function. The vertex of the arch is right up here at the top. Now, this thing weighs about 43 tons, so I can guarantee you that they started with the 60 foot in the ground. That's the foundation. In fact, if you're going to ride the tram to the top, you got to go underground to get on it. Down in this garage-like complex, you get on the tram, then you ride to the top. The vertex of our parabola, in this case, our parabola is pointing down, and the vertex is right there at the top. That's probably the last part they built. They probably didn't build this on the ground and then raise it with a crane, because that's 43,000 tons. It was built around 1963 to 1965. It took 2 years. Our parabola begins at the vertex and travels either upward or downward forever. Every parabola has an x squared function. It has an extrema in one direction or the other. The graph of a parabola would not just stop 60 feet into the ground. Our graph of our parabola would go on and on forever. This has a maximum height. The maximum height is right up there at the vertex. It's 630 feet, according to this picture. By the way, what happens when the winds blow? The engineers actually designed this so that if you've got a 20-mile-an-hour wind blowing on the arch, it sways 1 inch in either direction. And if you get hurricane force winds, near 150 miles an hour. Not that St. Louis gets a lot of hurricanes. But if it gets 150-mile-an-hour winds, the arch will actually sway 18 inches to either side so it doesn't break. Now, if our parabola is looking up, we have extremes. We have an extreme down here. It never gets below that point. We have an extreme up here. It never gets above that point. And you can clearly see on the graph what the point is. This one never gets below -1. If you were to graph it on your special calculator and hit the button, you don't have anything that comes out x is -4, x is -16, x is -20, because the last bit of my vertex here is -1. And here I have a vertex. Today you're just going to be finding the vertex. That vertex looks like 2, 7. It's right up there. And in this case, we have a minimum. No, not a minimum. We have a maximum here. It only goes up to that high. This is the minimum. This is the maximum. This one only goes so low. This one only goes so high. And one of the things you're going to do today is find the maximum and the minimum. What's the maximum on this? 7. It never goes above 7. In the other direction, you see the little arrows? It goes on and on and on forever. Now, I can't show you forever on the chalkboard, on the whiteboard, but it does. It goes on and on forever in its equation. We have a line of symmetry. Each parabola is symmetric about a line. That line goes straight down through the vertex. Sometimes the line of symmetry is the x-axis. No? Do you see any of those parabolas sideways? No, if it were sideways, it wouldn't be a function. You know that from the first chapter. So we're only going to talk about parabolas that go up, parabolas that go down. So the axis of symmetry could be the y-axis, but it would never be an x equals anything. Let's go to my graphing calculator to see a few examples. This is y equal x squared. What's the vertex? It's right down there. The vertex is the very corner, and you know that that vertex is 0, 0. It goes up and up forever. So we aren't going to talk about the forever. But does it have a minimum? Does it go down below? That's right. It doesn't go below the 0. Does it have an axis of symmetry? Yes. It's the y-axis, or x equal 0 is the equation of the y-axis, of course. Does it have a y-intercept? Yes, 1 at 0. Now, can I move this sideways? All right, I've now moved it sideways and down. It goes through 2 points on the x-axis. That is, we've got now I've got 1 point on the x-axis. Now I have 2 points on the x-axis. Could I actually come up with 0 points on the x-axis? That is, no solution, no real solution. Yeah, that particular parabola doesn't touch the x-axis. It still has a line of symmetry, which is x equal -2. It still has an origin. That origin, as you can see from my graphing calculator, did I say origin? What's the right word? Yeah, you're right. It's vertex. The vertex is -2, 3. The point starts at -2, 3. And the curve goes up. Can I make my parabola wider? I think I can. If I put a number here, what happened? Oh, I made that skinnier. Yeah, it still has the same vertex, but it's much skinnier. I put a whole number out there and it was skinnier. So let's see what happens when I put a fraction out there in front of the x squared. Have I made it bigger? I've made it bigger and I've made it wider. It has a vertex. It has a line of symmetry. It has a minimum. In this case, this parabola never gets below -9. But if you put a fraction out in front of that x squared term, it gets wider. If you put a whole number out in front of that x term, it gets skinnier. And we're not going to worry about the equations right now. Today, you're just going to do some IXL work where you are going to find the vertex, the line of symmetry, the maximum or the minimum on these graphs. And that's what we need to learn about the parabola today. Let's go back and look at our I can statements and see if I got them. It says I can recognize a quadratic graph. Obviously, you can recognize a curve in the graph. It's not a straight line. I can determine the vertex of the parabola. The vertex is the very beginning. It's either at the top or the bottom. I can find the maximum or the minimum of a quadratic function. Either it goes so high and goes down forever, or it goes so low and goes up forever. And I think you can do that. So I have completed my objectives for today. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.